Okay, so I'll take second problem on difference equation. Second problem, I'll just read out the problem. Solve by using Z transforms. Un plus 2 minus 5 into un plus 1 minus 6 un is equal to 2 power n, given that u naught is equal to u1, that is equal to 0. So this u naught is equal to u1 equals 0 is the initial condition of a problem. So this is the difference equation given. So I have to find the solution of this. That means I have to find what is un for this equation using Z transformation. Okay, so let us see how to solve this difference equation using Z transforms. First, solution given. So I'll write the given equation first. So here the given equation is un plus 2. Observe this carefully, very important. Minus 5 into un plus 1 minus 6 into un is equal to 2 power n, comma u naught equals u1 equals 0. This is the initial condition of a problem, right? So this is the difference equation and these are the initial conditions given in the problem. So what is the first step here? While solving a difference equation using Z transform, the first step is take Z transform on both sides. So I'll write taking Z transforms on both sides, we get, so the first term, it is Z transform of un plus 2 minus 5 into Z transform of un plus 1 minus 6 into Z transform of un is equal to RHS, it is Z transform of 2 power n, right? So I'm taking Z transform for each and every term here. Now we know the formula, we know that Z transform of un plus 1. So what is the Z transform of un plus 1? The formula is, this is equal to Z into u bar of Z minus u naught, right? So this is the Z transform of un plus 1. Z into u bar of Z minus u naught. So similarly, Z transform of un plus 2. These formulas already I have given in the last class. So for un plus 2, the function formula is Z square into it is u bar of Z minus u naught minus u1 by Z, right? So this is the Z transform of un plus 2. So I got the formula for this term and this term. And Z transform of un, it is u bar of Z. So and Z transform of un, straight away I can write this as u bar of Z and so what else we have? We have only 2 power n. And what is Z transform of 2 power n? So 2 power n. So it looks like k power n, and k power n, the formula is Z by Z minus k. K means, so it looks like Z transform of k power n. So the formula for Z transform of k power n is Z by Z minus k, and here k becomes 2, so it is Z by Z minus 2. So this is the formula list here. Let us substitute in this equation. So substituting, we get, substituting in the above equation, we get, so if I substitute in that, we get first Z transform of un plus 2. So the function is, it is Z square into u bar of Z minus u naught minus u1 by Z minus 5 into this term, 5 into this term, 5 into Z transform of un plus 1. Substitute now. Un plus 1, the formula is, it is Z into u bar of Z minus u naught. The next term, minus 6 into Z transform of un, and Z transform of un is u bar of Z is equal to right hand side. So Z transform of 2 power n, and Z transform of 2 power n is Z by Z minus 2. So it is Z by Z minus 2, right? So we have substituted all the functions here. So we have substituted. Now, once you have applied this formula, so what is the next step here? The next step is you have to use the initial conditions. So the initial conditions given are u naught is 0 and u1 is 0. Let us substitute in this. So u naught is 0 means this term was 0. Next u1 is 0 means even this term is 0. And here u naught is 0 means this term is 0. Correct? So this term is 0. So this term, and this term become 0 according to the initial conditions given. Now simplify the remaining thing. So it is z square into multiplying z square u bar of z square u bar of z. Then this term it is minus 5z u bar of z. Then minus 6 u bar of z is equal to right hand side, it is z by z minus 2. Correct? So we applied the formula, use the initial conditions, we get this. Now in left hand side, if you observe, this u bar of z is common in all the terms. You just take this u bar of z common. So this implies u bar of z common here. So what we get? It is z square minus 5z minus 6 is equal to z by z minus 2. Or I can write this as u bar of z equals, it is z by z minus 2 into, so let us send this to the right hand side here, denominator, it is z square minus 5z minus 6. So I get u bar of z is equal to, it is z by z minus 2 into z square minus 5z minus 6. Or I can write this as z divided by it is z minus 2 into, this is a quadratic expression, and you know in z transformation, if you find quadratic expressions or cubic, whatever it is, you need to factorize. You have to write this as the product of two terms. So what are the factors we get? So I can write minus 2 minus 3. Correct now? So you get z is equal to z minus 2 into z minus 3. So it becomes, correct, z minus 2 into z minus, so it is minus 2 here, minus 3z, so z common, so z minus 2, minus 3 common, I'll write here, z square minus 5z minus 6, z square minus 2z minus 3z. Oh, here minus of minus plus will come. The sign missing. Or 6 into 1, 6. You can write this as z square minus z plus 6z, or plus z minus 6z. Minus 6, so plus into minus 6. Okay, minus 5. Okay. Z common, it is z plus 1. Minus 6 common, it is z plus 1. So it is z plus 1 into z minus 6. So these are the factors, correct? So this is the factorization for this. So it is z plus 1 into z minus 6. Am I correct? This step. So the factors are z plus 1 into z minus 6. So just do the factorization so that you get a product terms like this. Now take inverse z transform on both sides. So taking inverse on both sides, we get. So it is zt inverse of u bar of z is equal to right hand side, it is zt inverse of z by, I'll write z plus 1 first, then z minus 2 into z minus 6. And you know zt inverse of u bar of z is un, so get un equals, it is zt inverse of, it is z divided by this z plus 1 into z minus 2 into z minus 6. Right? So this is un we got. So the difference equation was given to us. We have taken z transform on both sides and we have used the formula z transform of un plus 1, un plus 2 and z transform of 2 power in the right hand side. It is z by z minus 2. We have substituted all the functions. Then the terms u0, u1 for everything We have used these values and substitute and simplify. So finally we get u bar of z. So that u bar of z will be equal to z by z minus 2 into z square minus 5z minus 6. Factorize this. We get a product like this. Take inverse on both sides, you get un. Un equals inverse z transformation of the right hand side. So if you find the inverse for this, you will get what is the solution of a difference equation. So this is how we can solve a difference equation by using z transformations. The inverse z transformation of this. So let us consider. So consider, in the next step you will write z by this z plus 1 into z minus 2 into z minus 6. This is equal to. Now, how to write the partial fraction for this? Look here, this is linear non-repeated. For linear non-repeated, the partial fraction is a by first term, that is a by z plus 1 plus b by z minus 2 plus c by z minus 6. So this is what we have to do. But here in z transformation, what I am going to do is a by z plus 1. I'll write it as a into 1 by z plus 1. The numerator I'll leave it blank. So I need to do certain modifications. I'll write like this: a by z plus 1. This is actual partial fraction, a by z plus 1. But while writing, I'll write a into 1 by z plus 1. So this is because when we have z plus k or z minus k in the denominator, in numerator should be z. So I'll simply write z. So this is for simplification purpose. While applying the standard formula of inverse z transformation, this function should be in the standard form. So this is how we can express the function in the standard form. Plus second term. So it is actually b by z minus 2. I'll write b into 1 by z minus 2. So since here the power is 1, z minus 2 power 1. So the numerator should be z. So it looks like z minus k. If I have z minus k in the denominator, so numerator should be z. Plus the last term, it is c into 1 by z minus 6. So here also z minus k is there. I'll write z in the numerator. So I'll call this as equation number, say, 1. Right? So this is the partial fraction for this. Now you can take LCM and equate the numerators so that you can find the values of ABC. So let us find the values of ABC now. So straight away I'll take LCM and I'll straight away equate the numerators. Just do like this. I'll take numerators. Z equals, Z equals, it is the left hand side. See this? Here, this z plus 1 gets cancelled. This one, please. Okay. So the z plus 1 gets cancelled. So it is a z into product of these two. Right, the next page. It is a z into. So what is remaining here? Z plus 1 gets cancelled means it is z minus 2 into z minus 6. Z minus 2 into z minus 6. Similarly, plus b z into. So z minus 2 gets cancelled. It is z plus 1 into z minus 6. The last term c z into. So z minus 6 gets cancelled. It is z plus 1 into z minus 2. Right? So if I equate the numerators on both sides, we get this. And here z was common in all the terms. Just cancel z. Cancelling z on both sides. We get 1 equals, it is a into z minus 2 into z minus 6 plus b z plus 1 into z minus 6 plus c z plus 1 into z minus 2. Right? So after cancellation, you get this expression. Now in this expression, find the values of ABC. So what are the values of z I can give here? So let us put z is equal to. So just look at the roots. So here the roots of this is minus 1 here. Here it is 2 and here it is 6. So I'll put z is equal to minus 1 first. Then I'll put z is equal to minus 1 here. Then I'll put z is equal to 2. And finally I'll put z is equal to 6. so that I get the values of ABC. See, first if I put -1, so this expression becomes 1 is equal to the right hand side. See, this is -1, -2, it is -3, and here -1, -6, it is -7 into A, whereas B and C becomes 0, -1 plus 1, 0, and here also -1 plus 1, 0. So simplify this, we get the value of A. So A equals, see, this is minus into minus, plus 7 into 3, 21. So it is 1 by 21. Next, put Z is equal to 2. The left hand side, nothing is there. So it is 1 equals A, 2 minus 2, it becomes 0, plus, coming to the second term, here if I put Z is equal to 2, it is 2 plus 1, 3, 3, and here 2 minus 6, it is minus 4. Minus 4 into B plus C was 0. So this implies B equals, see this. So it is 3 into minus 4 is minus 12. So send it to the left hand side. It becomes minus 1 by 12. So this is our B. Now if I put 6 here, you get 1 equals, see this, 6 minus 6, this term 0. 6 minus 6, this term is also 0. So 0 plus 0. And coming to this term, it is 6 plus 1, 7. It is 7, and here this is 6 minus 2. 6 minus 2 is 4 into C. So this implies C equals 7 into 4, 28. So it is 1 by 28. So this is the value of C. So I got the values of A, B, C. So substitute this A, B, C. Substituting A, comma, B and C in 1, we get, in this expression. In this expression, if I substitute, we get it is Z by Z plus 1 into Z minus 2 into Z minus 6 is equal to, first term A was 1 by 21, 1 by 21 by Z plus 1, that B is minus 1 by 12 divided by Z minus 2 plus C is 1 by 28 divided by Z minus 6. Correct now? So in this expression, see, A, B, C was substituted. Sorry, so we forgot to write Z. Sorry, see, this is Z into Z here, into Z here, into Z is there. So now take inverse on both sides. This implies ZT inverse of, this is nothing but this term was our U bar of Z. U bar of Z is equal to this 1 by 21, I'll keep it outside. It is ZT inverse of Z by Z plus 1. Similarly, second term, minus 1 by 12 into, it is ZT inverse of Z by Z minus 2. And last term, it is plus 1 by 28 into ZT inverse of, it is Z by Z minus 6. Right? So I'm taking inverse on both sides. And you know ZT inverse of U bar of Z is UN. So you get UN equals, this is 1 by 21. 1 by 21. So what is inverse of Z by Z plus 1? So what is the inverse of Z by Z plus 1?
Minus 1 power n.
Minus 1 power n. Right. Minus 1 by 12 into, see, this is plus means you get minus. So it is minus 1 power n. And this is Z by Z minus k. So inverse of Z by Z minus k is k power n. So k means 2. So it is 2 power n. And last term, it is plus 1 by 28 into inverse of Z by Z minus k. K is 6 here. Sorry, this is plus. By 28. It is plus here, guys. I'm not able to write it down. Or I'll do one thing, just a minute. I'll write in the next line. Just a minute. So UN equals 1 by 21 into minus 1 power n minus 1 by 12 into 2 power n, then plus 1 by plus 1 by 28 into this is 6 power n here. So this is plus, guys. So here I don't know why I'm not able to write here. Vertical line I cannot able to write. So this was plus. I'll write this term below this, okay? It is not writing properly. Plus 1 by 28 into 6 power n. 6 power n. So this is the Z transformation of your, sorry, this is the solution of your difference equation, right? So this is how we can solve a difference equation by using Z transformations. So we'll start problem number 3. Problem number 3 now. So solve by using Z transforms. Solve by using Z transforms. The equation is un plus 2 minus 5 into un plus 1 plus 6 un equals 0. So this is the problem given. Let us see how to solve this by using Z transformation. How to solve this difference equation by using Z transformation. Now, what is the difference between last two problems and this? So the difference was, in the last two problems, they have given a conditions for this. We can look at this condition u0 and u1. They have given the values for u0, u1. But remember, guys, in this problem, the initial conditions are not given. Means you have to find a general solution. That means when you apply this formula, this u0 and u1 will remain as it is. Okay, so let us find what is the general solution of this difference equation using Z. Procedure is common, but initial conditions are not there. That's all. So first, I'll write the given equation. So first, given un plus 2 minus 5 into un plus 1 plus 6 un equals 0. So first step, as usual, you will take Z transform on both sides. So it is Z transform of un plus 2 minus 5 into Z transform of un plus 1 plus 6 into Z transform of un is equal to 0. Now apply the formula. So for un plus 2, un plus 1 and all, already the formula was written here. See, Z transform of un plus 2 is this. Z transform of un plus 1 is this. Just apply them. So first, Z transform of un plus 2. The formula is, it is Z square into u bar of Z minus u0 minus u1 by Z. Next, minus 5 into, it is Z into Z transform of un plus 1. It is u bar of Z minus u0 plus, this is 6 into Z transform of un is u bar of Z is equal to 0. Now let us multiply the Z square inside and we simplify this. So if I multiply inside, this becomes Z square u bar of Z minus u0 into Z square, and the next term u1 into this is Z square by Z, and Z square by Z is Z. Next, minus, multiply here, so it is minus 5Z into u bar of Z. So now minus into this minus, it is plus 5 u0 into Z plus 6 u bar of Z is equal to 0. Right? So earlier problem, u0 and u1 values we used to substitute, but here we cannot substitute that u0 and u1 values. So directly I'm retaining and simplifying. Now here what I'm going to do is, this u bar of Z terms I'll keep it in the left hand side, and other terms I will take it to the right hand side. Means I'll write this as Z square u bar of Z, this term, and this is the term containing u bar. So I'll write minus 5z u bar of z plus 6 u bar of z. This is also a term containing u bar of z. So these three terms, I'll keep it in the left hand side and take all other terms to the RHS. If I take it to the RHS, it becomes plus u naught z square. So this time I am taking our right hand side. Next this term plus u1 into z, this term. Next this term, if you take it to the right hand side, is minus 5 u naught into z. Correct? This term, and this term, you have taken it to right hand side. Right? So you have taken z transformation on both sides, the formulas are applied, you simplify. Now in the left hand side, you can observe, you can take u bar of z common. Let's go to the next page. So if I take u bar of z common in the left hand side, so what we get? We get z square minus 5z plus 6. Correct? See this. If I take u bar of z common, it is z square minus 5z plus 6. And is equal to the right hand side. In the right hand side, from this term and this term, I'll take u naught common. So I can write this as this term like this. This window is not moving. So then is equal to the right hand side. If I take u naught common, we get z square minus 5z plus u1 into z. Right now, so in the right hand side, see this. U naught is common from first and last. So it is z square minus 5z plus u1 into z. Now u bar of z equals. So this implies u bar of z equals, this is u naught into z square minus 5z plus u1 into z divided by denominator, it is z square minus 5z plus 6. Or I can take inverse on both sides and split this as zt inverse of u bar of z. I am taking inverse on both sides is equal to the right hand side. So I split like this. I'll keep u naught outside, u naught into this is zt inverse of this term. It is z square minus 5z divided by denominator z square minus 5z plus 6. So a by b plus second term u1 into inverse of this. It is z by it is z square minus 5z plus 6. Right? So it is like something like a plus b by c. I can write it as a by c plus b by c. So it is inverse. Inverse is not written here. Inverse. Okay. Or I can write this as zt inverse of u bar of z. You know it is un. So un equals, it is u naught into zt inverse of, it is z square minus 5z divided by, so factorize this. Okay, so if you factorize this one, we get, so the factorization is, I can write minus 2z minus 3z, minus 2 into minus 3 is plus 6, minus 2 minus 3 is minus 5. Okay, so z square minus 2z, z common means z minus 2, z minus 2, z square minus 2z minus 3z plus 6. If I take minus 3 common, so it is z minus 3. Correct, no? The factors z minus 2 into z minus 3. So z minus 2 into z minus 3. Just factorize it. Plus next term, it is u1 into inverse of it is z by denominator. Same. Z minus 2 into z minus 3. So this is the term we got. Let us call it as equation 1. So the difference equation was simplified by taking z transform, un plus 1, un plus 2 formula used and simplified. Since u naught, u1 values are not given, we got the equations like this. Now here the problem is you have to find the inverse z transformation for two terms. So this is one term, this is one term. You have to take them separately and find the inverse. So I'll take the first one and I'll find the inverse first, and then I'll take the second one, I'll find the inverse. So let us consider the first one. Consider the z square minus 5z divided by z minus 2 into z minus 3. So we'll find the inverse of this term and then inverse of this. So find the inverse of this now. So I can split this as A divided by Z minus 2 because linear non-repeated are there. So it is A by this term plus B by this term plus B by Z minus 3. So here you have Z minus K. If I have Z minus K, the numerator should be simply Z. Right. So now let us take LCM and equate the numerators. So it is Z square minus 5Z is equal to AZ into, see, Z minus 2, Z minus 2 gets cancelled. You get Z minus 3 plus next term it is BZ into, so Z minus 3, Z minus 3 gets cancelled. It is BZ into Z minus 2. Right. So we get this. Now cancel Z on both sides. It is Z minus 5 is equal to A into Z minus 3 plus B into Z minus 2. So because either sides you have a Z common, let us cancel one Z. So now find the values of AB. What are the values I can give? So I can observe 3 I can put and 2 I can put. So let us put Z is equal to 2 and then put Z is equal to 3. We get, if I put 2 here, it is 2 minus 5 equals. So it is A into 2 minus 3, whereas B becomes 0. So this implies, so it is minus 3 equals minus A implies A is equal to 3. Right? So A is equal to 3 from this. Next to put Z is equal to 3 in this equation, it is 3 minus 5. So 3 minus 5 equals A. 3 minus 3 it is 0. Here 3 minus 2 is 1. So it is plus 1 into B. So this implies B is equal to minus 2. Right? B is minus 2. So I got the values of A and B. So substitute A and B in this equation. Thus. So therefore we get Z square minus 5Z divided by the Z minus 2 into Z minus 3 equals first A. A is 3. So it is 3 into Z by Z minus 2. Next B. B is minus 2. Minus 2 into Z by Z minus 3. Right. So this A and B values are substituted here. Now take inverse on both sides. So it is ZT inverse of it is Z square minus 5Z divided by denominator. So Z minus 2 into Z minus 3 equals, see for the right answer directly I'll write answer so that I can at least avoid one step. So it is 3 into inverse of this. So what is the inverse of Z by Z minus 2? It looks like Z by Z minus K. K is 2. So the inverse of Z by Z minus 2 is 2 power n. Next minus 2 into, so inverse of Z by Z minus 3. So again same, Z by Z minus K, the answer is K power n. So K means 3. So it is 3 power n. So this is the inverse of the first term, and this I will call it as equation number say 2. Right? So this is the inverse of the first term here. Right? So the first term inverse we got. So similarly we take the second term and consider, resolve it into partial fraction and find the inverse. Now again consider the second term I take Z by, it is Z minus 2 into Z minus 3. So this is equal to, see, partial fractions already we did, only this 5 square minus Z will change. So it is A into Z by Z minus 2 plus B into Z by Z minus 3. Same procedure. Now if I equate the numerators, we get Z is equal to A Z into Z minus 3 plus B Z into Z minus 2. Same as above. Same as this one. See this. Everything is same. Left hand side, instead of Z square minus 5Z, you have Z. So if I cancel Z on both sides, if we cancel here, we get 1 is equal to A into Z minus 3 plus B into Z minus 2. Now put the values. Put Z is equal to 2 first, and then put Z is equal to 3. If I put 2, it is 1 is equal to, see, this is 2 minus 3, minus 1. So it is minus 1 into A, whereas B becomes 0. So this implies A is equal to minus 1. Next, if I put 3, The left hand side nothing is there. 1 equals 3 minus 3 0. 3 minus 3 0 here. But here 3 minus 2 is 1. So it is 1 into b. So this implies b is equal to 1. Right? So I got the values of a, b. So substitute them in this expression. If I substitute, we get, okay, just go to the next step. It is z by z minus 2 into z minus 3 equals. So here first a, so a is minus 1. So it is minus 1 into z by z minus 2, minus 1 into z by z minus 2 plus b. So b was 1. If I put 1 here, 1 into z by z minus 3. So it is plus 1 into z by z minus 3. Right? So a, b values are substituted here. Now take inverse on both sides. So zt inverse of the z by z minus 2 into z minus 3 equals, see here, straight away write the answer. So this minus, this minus. So inverse of z by z minus 2. You know inverse of z by z minus 2 is 2 power n plus. The next term, inverse of z by z minus 3 is 3 power n. So this I will call it as equation number 3. So this is the inverse of the second term here. Right? So whatever the term we have here, for this we got the inverse. So let us substitute our 2 and the next equation 3 in 1. We get the final answer. Substituting 2 and 3 in 1, we get un equals. What is 2? So 2 is 3 2 power n minus 2 3 power n. 3 into 2 power n minus 2 into 3 power n, correct? 3 into 2 power n minus 2 into 3 power n, and this one is minus 2 power n plus 3 power n, minus 2 power n plus 3 power n, sorry, into u0 and u1 are there, sorry, it is this into u0 and this is plus into this is u1. Okay, so I can rewrite like this. This implies un equals, it is u0 into, so it is 3 2 power n minus 2 3 power n plus u1 into, I'll write positive term first, this 3 power n first, 3 power n minus 2 power n. So this is the solution of your difference equation given. So this is the solution of the given difference equation according to Z transformation. This is how we can solve a problem of difference equation using Z transformation, and this is a common procedure for all problems here. The only difference between the first two problems and this one is, in the first two problem, we have given a value for u0 and u1, initial conditions, but in this problem, the conditions are not given for u0 and u1, so you have to find a general solution. So u0 and u1 will be there in the final answer. So this is the difference. This is how we can solve. So like this, there are many problems in difference equations. We can solve every problem of difference equation by using the procedure given here. So I'm going to write two problems here. So you can try these problems by using the procedure, whatever so far we have discussed. So and this is one of the most important concept here. So I'll just write the problem. Solve by using Z transforms. Z transforms. The equation is un plus 2 minus 6 into un plus 1 plus 9 into un, then into un is equal to 3 power n, given u0 is equal to 0 and u1 is equal to 1. So this is one of the important problem, guys. One of the important problem. This is 3 power n. 3 power n. Is there here? And So un plus 2 minus 6 into un plus 1 plus 9 un is equal to 3 power n, given u naught 0 and u1 is 1. So try this problem. And similarly, the fifth one, solve by using solve by using z transforms. The function is yn plus 2 plus 2 into yn plus 1 plus yn is equal to n with y naught is equal to 0, that is equal to y1. Y naught this is. So solve by using z transform, yn plus 2 plus 2 yn plus 1 plus yn is equal to n with y naught is equal to 0, that is equal to y1. So these are the two problems related to difference equations. So just solve these two problems using the procedure whatever so far we have discussed. Okay, so in the V2 examination, at least one question will be there on the difference equation. Solve difference equation by using Z transform like this. It was a very easy part. So easily you can do it in the annual examination.